All right, Algebra 2. Welcome to Unit 2. This is where we are going to start taking the training wheels off a little bit and really start to get into some Algebra 2 stuff. So buckle up. It's a good thing you've got some recorded lessons. If I go too quickly, just feel free to pause me, go back a little bit, see if you need to do it again. This video is going to be quite long. But again, you're expected to have about 30 minutes of pre-lesson work. And like I said, this is week 5. Welcome. So I'm pretty much going to be talking for this whole half hour, geez. For this entire half hour, as we work through this pre-lesson, much of it is a little bit of Algebra 1 review. And we thought that it would be a great way to spend your pre-lesson is just dusting off some of your brains about graphing points. That way today we can move forward with technology. So this particular situation, one of the cool things about this particular unit is that we're getting into linear functions and linear data. So as an input increases, so does an output, and same thing with decreasing. So there's so many amazing applications out there in terms of linear data. We decided to go with one that is currently kind of a hot topic in 2020, which is minimum wage. And we like to try to choose data sometimes that will directly relate to you guys, so you have a little bit of investment in this. As lots of you have part-time jobs, you know that what you get paid is kind of a big deal, especially at your age as you work your way through high school and then after. So just a little history about minimum wage. There is some information here. This is linked to your plan, so you have it as well. And this is, again, pre-lesson 2.1. So the first minimum wage, which I did not know, was 1938 at 25 cents per hour. Now, in 1938, think about what the dollar was worth in 1938. It's not very much. So there's two different kinds of minimum wages that we talk about. We talk about just what it was at the time. This is going to be your unadjusted minimum wage. But if we were to adjust that for inflation, so put it in terms of today's dollars, the minimum wage back in 1938, the federal minimum wage, would be about $4.45. So our current level of minimum wage was set in 2009. 2009. That's 11 years ago. And that was set at $7.25 per hour. So that you can see that since 1938 to 2009, if we look at adjusted minimum wage, it really hasn't changed all that much, about $3. So in terms of what you guys are getting paid, you might be saying, well, I get paid more than $7.25 per hour at my job at Panera or whatever. So typically, employers will pay the highest minimum wage, whether it's federal, state, or local minimum wage, rather than the minimum. So we're going to talk today about federal minimum wage. So as of this January, 20 states, that's not half, 20 out of 50 and Washington, D.C. had a minimum wage higher than the federal minimum. So we're going to look a little bit at history, and we are going to talk about first the unadjusted minimum wage. So I decided not to go back to 1938. Seems like a long time ago. So I went back to 1968 when it was at $1.60, and we are going to look at data all the way up to 2016, which was $7.25. It was also $7.25 in 2012, and it still is today. So the first thing that we're going to cover today in this pre-lesson is we're going to go back and cover some very important things about making large-scale graphs. So you guys made lots of graphs in Algebra 1. I teach Algebra 1. I know it. But it's been a while because you guys have been in geometry. So a couple things that are really important that is on this document that you have also linked to your game plan is some hints about graphing points. So when we're going to try to graph a set of data, hints that I will always hold you to is that we need to make sure instead of using 1,968, we're going to use t equals 0. So that would be our beginning of our information. So for us, we're going to let t equals 0 be 1968, which means rather than using 1,968. So now I need to figure out that's 4 years later. So that's 4 years later. 4 years after that, I've got 8, 12, And I hope that you guys are making a little table on a piece of paper that you have, because obviously you can't write on your document. So I'm going 28, 32, 36, 40, 44. Oh my goodness. All right, I'm a morning person and this is not the morning, so I'm going a little slower than usual. Okay, so I have my new T values, which means that if time is 0 is 1968, 48 years later was 2016. So that's the first thing we need to do. Second thing, we need to make sure that we use at least half of a page of graph paper when we're graphing data. I don't want a tiny little squished graph. That does me no good. So when I'm gonna set up this data, I've got my graph paper. I'm hoping you have your graph paper. I warned you about this on Thursday and Friday. You can pick up graph paper at Meijer. That's where I got my kids' graph paper. I think it's like $1.39 per pack. If you cannot get graph paper, please let me know. I will be happy to provide you with some graph paper somehow. So I'm gonna set this up a really big graph. As you can see, I've got kind of the bottom half of the graph paper here. I want to use at least a half a sheet of graph paper. The next one says, consider using a graph break. So a graph break would be if I was graphing something that was way above 0. So in this case, I only have $1.60. I'm thinking I can probably start at 0. And again, here is another chance to start at 0. So I do not need to use a graph break. Equal intervals for all inputs and outputs, and make sure that we label our axes. All right, so moving this along a little bit, I am going to now take a look at my data, and I am going to put it on this graph. So I can see that the unadjusted minimum wage in the US federal depends on time, which means I'm gonna start with my time axis. Usually I find that the inputs are a little bit easier, usually whole numbers. So when I label my axis, I'm gonna label my axis time. And I'm also going to tell my audience that T of 0 is 1968. That way they have every piece of information that they need. I'm going to start at 0. So if I need to get out to 48, there's no way I can go by ones, I don't think. And I need to make sure that I get at least halfway or more when I spread these all out. So I also don't want to go by tens. If I went by tens, 10, 20, 30, 40, this would be the tiniest graph ever. So I need to spread it out more than half of the graph. I'm thinking I can go by twos. So I'm going to go 2, 4, 6, 8. Hey, I'm an algebra 2. If I don't need to write every single 2, I'm not going to, and I do not expect you to. As long as your reader can tell that you are going by 4s, then we're good to go. If I were you guys, I would certainly use pencil when I made my graph to start. That way, if I make mistakes, my life isn't crazy. As you can see, when I was making this assignment for you, I made some errors because I had to go over it with my pen. So I would strongly suggest some pencil. All right, so here's my times. I've spread it out. It's more than half. I'm incorporating all of my T values. And now I need to figure out what to go by, or my intervals, for talking about the minimum wage. Right now, unadjusted minimum wage is $7.25. Way back in 1968, it was $1.60. So that's really only $8 that I need to fit here. And as I know about money, I could go by like 50 cents, right? So I'm gonna skip one and I'm gonna call that $1. Skip one, $2. Skip one, $3, $4, $5, $6. As long as I get halfway or more, I'm good to go. $7, $8. The highest minimum wage I have is $7.25, so $8 is gonna work. And now, of course, I'm going to label my axes. So this is the minimum wage, federal minimum wage, unadjusted for inflation, and this is in US dollars. Okay, so that's the hardest part. As you remember from Algebra 1, the hardest part is setting up your axes. Once you're here, then you just have to go right through and plot all your points. So I'm gonna do this pretty quickly. You might have to pause me, but I would love it if you would do this by yourselves as well. Pause me for a second, then you can fast forward, and when we're done, we should have the same graph. So I've got 0, 160, 4, 160, 8, 230, so that's going to be about right here. 12 is up at 310. So again, I can be precise, but I don't have to be like laser sharp focus precise. When we get into class today, we are going to start using your some Desmos online graphing calculator technology in order to get absolutely precise points. This one, you just need to be as good as you can be. So 28, 475, and I'm sure you remember this from Algebra 1. 32, 515, 36, 515. It's interesting when you go through how long minimum wage actually stays the same over the course of some years. So after 40 years, 2008, whoa, that was a big bump. I'm up to $6.55 per hour. 44, I'm up to $7.25, and then 2016. Okay, so I can see in general that over the course of time since 1968, minimum wage has been going up. There are some periods of time where it stays pretty much the same, but I think we could generally say that this is an increasing trend, and we can absolutely make a line to model this trend. So step number 1 is to make this graph. Step number 2, because we are doing everything by hand, again, a little bit of an Algebra 1 review, perfect moment for it. Welcome back to linear functions, is if you look at part 2 of our activity, it says we need to draw a line of best fit to estimate the trend. Now, back in Algebra 1, I, of course, am wondering if I have a ruler. Good thing I do. Okay, back in Algebra 1, at least I remember when I used to teach Algebra 1, I would just kind of tell the kids, well, you just kind of make sure it goes through all the points. And we're going to up our game a little bit this year. We are going to use what's called the mean point. So in order to create an excellent line of best fit, we are going to calculate what's called the mean point. So the mean point is going to be average x's, average y's. So we're going to try to get the average value of all your inputs and the average value of all of your outputs. So right here on my graph, because, you know, I don't like to waste too much paper and I've already got this beautiful graph going, I'm going to just list my mean point. So this is something that's going to be a little bit new this year. So the mean point is going to be average x's and average y's for whatever data set I'm using. So when I find the average x's, that's right, add up all the x's, divide by how many they are. So I've already done this for you. If I were to add up all of the x values, 4, 8, 12, 16, 20, 24, add all those up, the total actually ends up being 312. I divide it by 13 total data points. There were 13 data points that I was given. If I do the same thing for the y values, I end up with a total of $55.65, which we know is not the average. That would be some pretty awesome minimum wage. And again, I'm going to divide it by 13 data points. So my mean point for this situation is 24th year, $4.28. And I did that ahead of time just to save you. So this is going to be my average, which means that this is going to be right in the middle of all of our data points. So the first thing that this says is, when I look back at my steps here, calculate the mean point, and then plot the mean point as a star. The reason why I plot this as a star is that this is not a data point. We do not want to get confused and think, oh, that's a data point. No, it's not. This is a calculated value that has nothing to do with points in time for this situation. So I'm going to graph 24, 428. And if I did it correctly, oh man, I think this value was actually 24, 425. So this is pretty close. I'm going to put my star right above that previous point. Sometimes I like to highlight it. I'm a big highlighter fan. So that way I know that that is not a data point. That's just the average of my X's and the average of my Y's, which should land you kind of right in the middle of your data point. If it didn't, you did something wrong, try again. Okay, and then the last step is now to elevate our Algebra 1 concepts of a line of best fit to model this data. I'm gonna make sure that my line of best fit goes through the mean point. It has to include the mean point. And again, I'm going to try to, you're going to try to have the same distance above the line as you do below the line, the same amount of error as if I were going to put this right here, and I'm just trying to get the same amount of error above and below. And every time I draw this line, I'm going to draw a slightly different line, which is always a little interesting as I'm doing a bunch of answer keys for you guys. All right, so I don't know. I think I gotta move it up a little bit. It does not have to go through 0, 0. So let's see how I did. Well, it could have been better, but it's not bad. As you can see, and we'll talk about this in pre-calc, the distance, the error in the positive, I've got, I don't know, that's about maybe 2 units worth of error, but look what I ended up with in the negative. That's like 1, 2.5, 3, 4. Okay, so I ended up with a little bit too much error underneath it, but you know what? It's my first line of best fit. I'm not gonna feel too badly about that. So now that I've got that line of best fit, I can actually use this line to make some analysis. This is the point of this. Let's analyze our situation according to this line that I drew. We can make some predictions, and we can talk about what's going on. So I've asked you 2 questions on your activity, and we're going to actually use the line of best fit. So I'm in part number 3 right now. Part number 1 was to make the graph. Part number 2 was to find the mean point and draw our line. And part number 3 is now to actually use that line of best fit. Why on earth would we waste our time with that line? So the first thing asked us to find U of 36. Okay, U of 36. Well, where did the U come from? Oh, that's right. Way back up here, this is the unadjusted minimum wage. So this is going to be U of T. Good thing I caught myself there. All right, so at an input of 36, my line says at an input of 36, my line says that minimum wage should be about $5.75. So I'm going to say $5.75. So at year 36, or 2004, my line says that unadjusted minimum wage should be about $5.75. Well, how does that compare with actual data? Well, my actual data table says that in 2004, which was year 36, the actual was $5.15. So it's a little higher than what our actual was. So this is called our predicted value, and this is called our actual value. And the closer those are, the better your line of best fit. Okay, the next question asked, use your line to determine what U of T will be this year. Okay, wait a minute. This year is 2020. The last point that I had was 2016. So 4 more years. I need to look at 52. Okay, so I'm looking at U of T or U of 52. All right, well, I didn't have any data for that. So this is one use for my line. According to my line, unadjusted minimum wage should be, oh, I better put that as a star, should be about $7.50. And we know actually that right now, so this again is our predicted value based on our by hand line. We actually know that in 2020, the minimum wage was still $7.25. So the actual is a little bit lower than the predicted. Okay, so by hand lines of best fit, super useful, super helpful. But again, there's a lot of margin for error here because you're doing this whole thing just kind of using your eyeball instead of using actual technology to make your line. So thank you for bearing with me. I know this was kind of a long video. I'm sorry. But again, this is a really good time to kind of dust off the brain, see what you remember. We are going to be doing a lot of graphing data points, and we're going to use a bunch of technology as we get into class today. So when you get to class today, please make sure that you have your graph filled out, ready to go. We are not done with this graph. We are actually going to use this graph again. So if you found yourself in this pre-lesson just sitting back and watching, I'm going to encourage you to go back, rewind, and you need this graph drawn so that we can do some analysis with minimum wage as we move forward into class. So hopefully you kept up with me and your job is done. If you did not, I've still got 9 minutes left on my 30 minutes of time. So go back, rewind, make yourself a graph. All right, thanks little ones. I'll see you in class. Bye-bye.